Hello and welcome back to Pharma-info with Shubhashish. Now today the topic is synthesis of dicyclomine, right? Okay, in my last video you might have gone through the last video, that is of a cholinergic agonist carbachol, right? Now today we just move to dicyclomine. This is also there. So according as per the PCI syllabus, okay, the synthesis of dicyclomine has to be studied, right? So dicyclomine is an example of cholinergic antagonist, cholinergic blocker, right? Essentially act as a spasmolytic, okay, cramping of your intestine, right? This is the drug of choice. When a subject is suffering from cramping of intestine and all, because there is an excess spasm of your intestine and smooth muscle will get contracted, it's getting contracted, and which eventually leads to the cramping and all. Okay, that can be cured, that can be alleviated rather with the help of dicyclomine, right? That's dicyclomine is an example of muscarinic antagonist, right? Okay. So dicyclomine, let us just go to the structure and then we'll move to the IUPAC naming and subsequently the synthesis, right? Okay. So dicyclomine, dicyclo, that means two cyclic system, right? Two cyclic system. So two cyclic system, how they look? Something like this. It's not a biphenyl, rather we have removed the pi bonds, right? It's, both are cyclohexyl, cyclohexane, something like this. Cyclohexyl, cyclohexane, right? Okay. Now we all know that there are several chemical classes or classes of cholinergic blockers, synthetic cholinergic blockers, like your amino alkyl ester, then amino alcohols. So all these things are there, right? So now let us see that so dicyclomine belongs to the chemical category of amino alkyl ester, right? Amino alkyl ester. So we have two bulky ring system, right? Followed by ester means C double bond O. Alkyl means we have a chain of two carbons, right? And followed by nitrogen. That should be a tertiary. For the proper affinity to grow, the terminal amino should be made what? Tertiary. Now here, the substituents are found to be ethyl. Both are found to be similar, right? So this is found to be the structure of dicyclomine. Now, how the IUPAC name goes? Again, we'll just give importance to the to the rule, like OSNP. So comes first. So likewise, this is found to be the substituent. So this is the position 1 and 2. Second is holding what? Diethyl amino. We are done. Followed by ethyl. Then 1 is holding what? 1 is holding cyclohexyl. So 1 cyclohexyl, cyclohexane, 1 carboxylate. This should be the way of naming, okay, following the IUPAC rule and all. So what I told, O has to be given the preference. So it's 1, 2, 2 is holding what? Diethyl. So you just put 2 followed by diethyl amino over, then ethyl, then 1. 1 is holding what? 1 of this, the pairing, the ester, right? 1 is holding what? 1 is holding cyclohexyl. So 1 cyclohexyl followed by cyclohexane and then carboxylate. So this is the way you should name what? You should name it following the IUPAC rule and all, right? Okay. Now let us move to the making of dicyclomine. So in the process of making the dicyclomine, okay, you have to, again it has to be fragmented into possible fragments, and culturing the fragments we may end up to what? The essential reagents which are involved in making what? Dicyclomine. So what are the possible reagents, right? So this is the structure of dicyclomine. From where this can be broken? It can be broken down into possible pieces and all, right? Okay. So what are those actually? So we can, this can be broken down from here. This is one of the region, right? This is the other region, right? This is the other region. So these are the possible fragments, right? Which are obtained from the dissection of what? Dissection of dicyclomine, right? Okay. Now let us see that what are the possible outcome of this fragmentation process, right? Okay. So what are the possible outcomes? The possible outcomes are found to be, if we just break this particular bond, which actually connect this two cyclohexane ring system, right? So how this can be, they can be merged, because we have to think it in a manner so that we can just merge them all together, right? So it's better like if we just put one halogen here, like cyclohexyl bromide, and here we have to remember that from this carbon only the ester moiety is what? Is protruding rather. Right? So this is found to be the root from where the carboxylic moiety, okay, is emerging rather. Okay. So here we'll just put something like this: cyclohexane nitrile, alkane nitrile, alkane sulfonic acid. So cyclohexane is an example of alicyclic compound. That is why cyclohexane nitrile. So it's better to write cyclohexane nitrile, and this one is cyclohexyl bromide. These are the two reagents, the starting mixtures, right? Okay. These two starting mixtures interact with each other, and there is a formation of what? Okay, and there is a formation of like this, C triple bond N. Now what I do? What should be done? This has to be made what? This has to be hydrolyzed. Right? This has to be hydrolyzed, acidic hydrolysis, right? In presence of alcohol, right? So acidic hydrolysis in presence of alcohol leads to what? So I'll just write like this, C2H5OH, because we have to make it what? C double bond O. Okay. So while treating this particular intermediate, that is first intermediate with this, what will happen? This will get converted to an ester. Now what is left in the process? To this particular ester, what is there? The next thing is CH2CH2N. Dicyclomine means C2H5 whole twice. Diethyl amino ethyl, right? So we are done with this, up to this, right? Now what next? So that means this is the one which has to be introduced in the form of an alcohol. That means we need to react this newly formed ester. That means this is found to be the second intermediate, right? After hydrolysis, this will get converted to an ester, right? So if we just say a process which involves the reaction between an alcohol with an ester is called transesterification. So here we have to use the concept of what? Transesterification. That means when one half of an ester is replaced with a bigger ester. Got my point? So now we have to bring the concept of transesterification. Transesterification. So what is this transesterification? Transesterification means you are replacing a lower member with a higher member. It's a simple thing, right? Okay. So what is that lower member and higher member, right? Okay. So this is COOC2H5. Now let us bring the second, the final one, like alcohol, like this. Sorry, C2H5. If we just compare, this one is earlier ethanol, right? This is no longer ethanol, right? To that ethanol, the diethyl amino portion has already been added. So that means if we just compare the volume of both this and this is found to be voluminous than this. So that means we are just trying to replace the smaller member with a bigger member. So this process is called as transesterification, because we are not changing the parent. The parent will remain same. Only thing is that to that parent, the offsprings, or rather the substituents are found to be bigger. So it has become a bigger. Earlier it was ethyl. Now ethyl has been converted to diethyl amino ethyl, right? So this is called transesterification. Now at the verge of completion, rather at the terminal step, we have to bring this alcohol. That means diethyl amino ethanol, right? Okay. So this is the alcohol that has to be brought, and when this particular alcohol will react with this, with the second intermediate, so what will form? This will get formed. CH2, CH2N, C2H5. So with that we are done with what? The making of dicyclomine. So what we did initially from the starting, so starting onwards, what we did initially, if we just try to, present it in a brief way. So what we did actually, so initially we have taken 2 cyclohexane like this. One is cyclohexyl bromide, the other one is cyclohexane nitrile. We reacted them all together, and there is a formation of what? Like this. Like this. So this is basically one cyclohexyl cyclohexane nitrile, right? Okay. Now then what I did, actually acidic hydrolysis in presence of an alcohol, so leads to what? The formation of an ester like this, and to that ester, with that ester I just reacted what? The bigger alcohol, that is CH2CH2N C2H5 C2H5. So what is getting formed? This is the final thing that got formed, like C double bond O, O, CH2, CH2, N, C2H5, C2H5. Our desired compound of interest, right? And this process is called as, when we are replacing the smaller with the bigger one, that process is called as transesterification, because we are not altering the parent. The parent remains same. Only thing is that we are just magnify the substituent. Got my point? So this process is called as transesterification. So with that I am done with the making of dicyclomine. Hope you have liked this video. Hope you have enjoyed the session, right? If you like my videos, please don't forget to press the like button, and please do share my videos, and please subscribe my channel so that you and me both will grow, right? Thank you very much. Thank you for your kind patience.